For each of the following polygons, write a formula for the perimeter and area using the given variable length. So before we do that, let's take a look at each one of those things, the perimeter and area, as two forms of measurements that are associated with two-dimensional shapes. All right, so here I've got myself a square, and if I wanted to find the perimeter of the square, basically what I'm doing is I'm taking its side lengths and basically lining these things up. Where are you going? Let me grab that thing that I just made. And since this is a square, all the side lengths, of course, are exactly the same. So I'm just going to duplicate this up. So duplicate, whoop, and again, and again. When I string all of these things together, it makes one big line segment. And if I were to measure the length of this thing, that would be the perimeter, of course. And this is just a length. And it is one-dimensional. 1D. Not 2D, not 3D, one-dimensional. And anytime that you measure perimeter, you're measuring it in linear units. What I mean by linear units is inches, feet, centimeters, meters, miles, stuff like that. You're not measuring it in, say, two-dimensional or square units, quadratic units, like inches squared, feet squared, and centimeters squared. What do you use that for? Of course, you use that for area. Area is a different kind of measurement associated with shapes, and it basically asks you to do this. Wait, where do I have this? I have this on my stickers. There we go. Boop. And hey, it didn't go in. Add. Boop. When you're trying to find the area, you're basically trying to find out how many of these squares it would take to fill this thing up. So let me try to do this. And if it would cooperate. Oh, that's because I'm on the wrong thing. Dupe. This is riveting, right? Okay, so you have one row here, and there's 1, 2, 3, 4, 5, 6 of them on here. And then to speed this up a little bit, maybe what I do is I duplicate that whole entire row, delete that out. And so now we have 2 of those. Do that again. And now I've got 4 of those. And then it looks like it's going to need 2 more, right? So I'll just duplicate just 2 of those. And delete. So if I wanted to find the area is basically how many squares. And as far as this goes, it was 6 across this way, it's 6 across this way, so that's a total of 36. This is a two-dimensional form of measurement, 2D. And anytime that you measure area, you need to have quadratic units instead of linear units. And so quadratic units look like inches squared, feet squared, centimeters squared, and so on. All right, so now that that discussion's out of the way, we've got various formula for each of the different shapes so that you don't have to actually put in all of the little squares and count up all of the individual squares. And the same thing with the perimeter, you don't have to line up all the sides. Instead, we develop formulas for these. Now, one of the first lessons that we're going to do at the start of honors geometry is that we're going to understand like where all of these various formula come from. But for right now, we're just kind of recapping what we would have gotten from, what is this still? Is this still 6th grade? Still 6th grade math. Okay, so square, as far as your perimeter goes, your side length, we're going to use the letter S, side length, and you've got 4 of those things. It's S plus S plus S plus S, which is the same thing as just 4S. Now, as far as its area goes, just like the one that I did up here, It's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. It's 6 by 6, which is 36. Or you can get that by just 6 squared, which is usually what we do. It's the side length squared. Okay, for a rectangle, we would have 2 of these W's and we have 2 of these L's. So sometimes this is written as 2 L's plus 2W, or you can factor out the 2 and make that 2 parentheses L plus W by distributive property. And as far as its area goes, it's going to be the length times the width. Now, the length doesn't have to be bigger than the width, and the width doesn't have to be on the bottom. Sometimes people say this is base and height, but it all is the same, length and width. For a triangle, its perimeter, nothing special. It's just adding up your 3 sides, and who knows if any of your sides are going to be the same length or not. So it's just the sum of these is A plus B plus C. And as far as your area goes, area is the base times the height divided by 2, or half of that. And again, we're going to see why that is the case at the start of honors geometry this year. 1/2 base times height. Base times base. Try that again. H. Okay. And then a trapezoid. Trapezoid, a little bit strange. This B1 and this B2, those are the 2 bases. The little arrows here mean that these things are parallel to each other. You got one set of parallel sides, and these 2 that are not parallel to each other are called the legs. They can be the same size, which would make it isosceles, but it doesn't have to be. So as far as perimeter goes, again, kind of like the triangle, there's nothing special here. You just add them all up. So you have an A plus a B1 plus a C plus a B2 in whatever order you want to. Order, it doesn't matter here. As far as the area of the trapezoid goes, it's going to look like this. It's 1/2. The sum of the 2 bases, put that in parentheses, B1 plus B2. And then you're going to multiply that times the height. And the height in both this case, and whenever we get to the parallelogram, the base and the height have to make a right angle right there. They have to be perpendicular. And then finally, a parallelogram. A parallelogram, you have 2 bases and you have 2 A's, 2 B's. Where's my pointer? There we go. 2 B's and 2 A's. It's sort of like the one for the rectangle. So you can write that as 2A plus 2B, or you can factor out that 2, and that's 2 times A plus B. And then finally, for your area, it's just straight up base times height. You don't multiply the A times the B. That's not going to work, not unless the A and the B are perpendicular, make a right angle like they would for a rectangle. So it's the base times the height, and that's it. Now, as far as the rest of the problems go, 15 through 19, you're just essentially applying each one of these formula to the appropriate shape. And it's pretty obvious because it tells you which one you're supposed to use: a square, the rectangle, a triangle here for this one. And now notice for the first time on number 17, this is one where you have to work backwards. Anytime you have a formula, working forwards essentially means that they give you what we would call the independent variable, and then you're finding the dependent variable. You plug in the side length, you find the perimeter. You plug in the side length, you find the area, and so on. Here on number 17, however, they're wanting you to find the base if you know what the height is and you do know what the area is. So you would be working this essentially backwards, plugging in your area, plugging in your height length, and then solving that for your base. Number 19, I skipped 18. We'll come back to it in a second. Number 19 is very, very similar to 17, parallelogram, but it is another one of those that you are working backwards because you have the area, you have the base length, and you're figuring out what the height is. Now on number 18 with the trapezoid, choop and choop and choop, just understand 2 things. First of all, it says area, it doesn't say perimeter. And the reason why it doesn't say perimeter is because of these slanty sides. When you're on a graph grid, you can easily count things that go horizontally as far as boxes go. Like, for example, if I were to draw myself a segment in here, I know that that thing is 3 units. But if I were to draw this thing, let's say vertically, can I do the same thing? Is that also 3 units? Yes. So you can measure vertically, you can measure horizontally by counting boxes, but you cannot measure diagonally like this. This is not 1, 2 boxes. And the reason why is because if you take a look at this, it would essentially make a right triangle, and you'd have to use the Pythagorean theorem. And we know on the Pythagorean theorem that the hypotenuse is always the longest one. Pythagorean theorem hasn't been introduced yet, not in 6th grade, which is why this one's only asking for the area. So remember, we can measure horizontally, we can measure vertically by counting up boxes, but we cannot measure diagonally.